In this video, we're going to talk about three-dimensional coordinate system. And in this, we're going to focus on the cylindrical coordinate system. So at the end of this video, you'll be able to, one, convert the Cartesian coordinate system into the cylindrical coordinate system, and also convert the cylindrical coordinate system into the Cartesian coordinate system. And with equations, you'll be able to convert an equation in a Cartesian plane to a cylindrical coordinate system, and also an equation in a cylindrical coordinate system to a Cartesian coordinate system. So one may ask, what is a coordinate system? For a coordinate system, it's a way of using numbers to determine the position of some point in space. This is the case that we have one-dimensional coordinate system, two-dimensional coordinate system, and three-dimensional coordinate system. So for a 1D coordinate system is denoted by R. So from multivariable calculus, whereby we will deal with R squared or R cubed, but in this video you're going to talk about R cubed, which is the three-dimensional coordinate system. So for the an example of the one-dimensional coordinate system is x is equal to 2. With the two coordinate system, it's represented by R exponent 2. This means that it involves two variables, which is x and y, and the points will be given as -1 and 5. That's an example. With the three-dimensional coordinate system, it is represented by R exponent 3, whereby the variables involve x, y, z, and an example is 13, -3, and 7. So in this case, what you're going to deal is about the three-dimensional coordinate system. So we have a general rule for you using the coordinate system, whereby when R is exponent n, whereby n starts with 1, 2, 3, and in this case, we're going to deal with R being equal to 3. So whereby n be equal to 3, that is R exponent 3, means a three-dimensional coordinate system. So let's have a look about something. Let's see how we can plot the three-dimensional coordinate system on a normal plane. So this is a three-dimensional coordinate system whereby we have x, y, z, and in this case, let's take the variables 1, 1. For R, this point, we have it to be 0, x, z. No, 0, y, z. In this case, x is 0, y is x0. So for this, you have a reference point, which is from the origin here. And we are moving to this side. Then we are going to move on the y-axis, then move on the z-axis. So in this case, we didn't move on the x-axis. That means that the x is 0. Then we move into this plane. We're going to move this side, then move this side. So we're going to move on the x-axis and move on the y-axis. But we didn't move on the z-axis. So that's the whole idea we are using for all. And for this point, we are moving on both x, y, z. And here, we are moving on the x-axis and the z-axis, whereby we don't move on the y-axis. So this is how we can plot it on a three-dimensional coordinate system. Let's move down. So this is the explanation that I just did with the diagram. So here we don't need to go through because I've really explained that. So then what you need to talk about is how to find a distance between 2 points. So in this case, the distance we are talking about is the two-dimensional coordinate system, whereby the formula goes that when 2 points are given to you and they're asked to find the distance between those 2 points, what you must do is that you're going to take x2 minus x1 all squared plus y2 minus y1 all squared and all in a square root. So with this, they're going to give you 2 points, and a point we have maybe 1, 1. We have 1, 1 here, 1, 1, and maybe have another one which represents maybe 1, 2. In this case, depending on your x and y value, this can be your x1, this can be your x2, this can be your x2, this can be your x1. But all this, you're not going to get a negative value because of the square. So anyhow you take it, you're going to get a distance correctly. So in a three-dimensional coordinate system, when 3 points are given to you, P1, P2, and here should be P3, right? what you must do is that you're going to have the same principle whereby you're going to take x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared, right? So now let's look at something. Likewise, the equation of the circle. So with the equation of the circle, it's going to help us with the convection. That is changing the Cartesian coordinate system into the three-dimensional cylindrical coordinate system, right? So in this case, we have a circle. The general equation for a circle with center HK and a radius R is given by this. So, but you using the coordinate system, we take the center of the circle from the origin. So therefore, H and K becomes 0. So when you reduce the formula, you're going to get that s squared, because if this one becomes 0, it will cancel out. So you're going to get x squared plus y squared is equal to r squared. Please, let's take note of that formula very well. The same thing applies to the coordinate system, that is the general equation for the sphere with center HKL. In this case, you're taking the center from the origin, and that's it. But with this video, I'm concentrating on the cylindrical coordinate system. So let's take some example. How do you represent the 1D, 2D, on a 3D on a graph? So with x equal to 3, this is only on x-axis, right? So you have the normal plane, and you're just given a point. So it is just a point. And let's move on to, on the 2D, we have x and y. The points we're given to. So then we're going to have, on they say that x is equal to 3, right? And in this case, it means that y is 0. So you just move on the what? The 3 on the x coordinate system. So to be a line, you know that x is equal to 3 is a line. And on the cylindrical coordinate system, so in this case, this is what we used to represent it on 3D and 2D, right? So let's talk about the cylindrical coordinate system. So this is the main thing that we are here. So with the cylindrical coordinate system or cylinder, it's an extension of the polar coordinates into 3 dimensions, right? So whereby we add z to it. So the coordinate system that we need to know about the cylindrical coordinate system is that we have the r, the theta, and the z, which forms the cylindrical coordinate system, which is also known as the polar coordinate system, right? Sure. So with the cylindrical coordinate system, we convert the Cartesian coordinate system into radius, theta, and z. One may ask, how do you do that? So first, from what I established from the equation of the circle with center HK, we established that we are taking the center from the circle. Therefore, r squared will be equal to what? X squared plus what? Y squared. So when you simplify this correctly, you're going to get that r is equal to the square root of x squared plus y squared. So we've established one. So how do you get r? When the Cartesian coordinate system is given to you, right? What you must know is that for you to get the r, then you're going to square the x, square the y, and all square root. But in this case, z is the same, because with a three-dimensional coordinate system, they're going to give you x, y, z. And in this case, for the cylindrical coordinate system, we maintain the z, but change the x, y into the radius and the angle. So you can see that this is the radius and this is the angle, and this is the z. The z doesn't change from the diagram. The z doesn't change, but what you have is that the theta and the r, that's what change using this one. So let's establish something here. So this is the relationship between the coordinate system, that's the Cartesian coordinate system, and the cylindrical coordinate system, right? So in this case, we have the formula that states that x is equal to r cos theta. Let's take this note. Y is equal to r sine theta, and z is equal to z. So whenever they give an equation, right, and then you are asking, in this case, we are trying to change the cylindrical coordinate system into the Cartesian coordinate system. So in this case, when they give you the radius and the angle and the z, you changing the radius and the angle and the z to the Cartesian coordinate system. For us to find the x, you're going to just take the radius, multiply by cos times the angle given, and for r, you take the radius multiplied by the sine of the angle given. The z doesn't change. So let's look at how you can also convert the a Cartesian coordinate system into cylindrical coordinate system, right? So for us to find r, we've established already that r is equal to the square root of x squared plus y squared, and theta is equal to the tan inverse of what? Y over x, and z is z. So this is very simple. So for this, just need to have the formulas in your head, and that's all. So let's take some example here. So with this example, they are asking us to convert the following to what? The Cartesian coordinate system into what? Cylindrical coordinate system. I know you can do it because they've given us our x, y, and we have our z. So automatically you already know your z. Then for us to find the tan, for us to find the theta, you know that the theta. But all the same, do you know something? You can use calculator to convert this. Check the description of this video to know how you can use calculator to just do this very simple without stress, right? But all the same, you need to do handwork and understand. But the calculator will help you verify to see whether your answer is correct. That's very simple as that. And also the number 2 is you using equation form. So for equation, you know that x is equal to r cos theta. So here will be r cos theta cubed plus 2 r cos theta squared minus 6z is equal to 4 minus 2 bracket open r sine theta squared, and you do that. And in this question, they ask us to convert the cylindrical to this one. You know that for us to find r, right, r is equal to what? The square root of x squared plus y squared. So you substitute it here, and we know that the r is equal to r squared is equal to x squared plus y squared. You just do the substitution and yes, you are good to go. So that's why I told that with this, you just need to know the substitution and this one. All the same, check the description of this video for the video. And thank you very much for watching this video.